Hey folks, we're back and checking in on the Compost powered hot water heater and how it's doing. It's about 6 weeks later, and yeah, I've been getting some hot water, and I'll talk more about that in a second. But here's the pile. We had a low of 4 degrees Fahrenheit last night, so pretty cold, and it's been cold. It's the coldest winter we've had in some time, so been enjoying that. But let's see how it's affecting the pile. All right, inside here I've got the bucket set up like I did when I first set it up, and somebody in the YouTube comments mentioned that the thermal siphon only works if it's submerged in the water. Before, I just had it spilling out and it wouldn't work, but I put this extension on and got it underwater and it started siphoning. And at the beginning I was getting 123 or something, kind of peaked at, and then after that 111 was a pretty common temperature that I was getting out of it. But the siphon worked well and all of that, and right now I have the siphon turned off and it's at 80 degrees, and that's largely because it's next to a rocket mass heater that's been running for 3.5 hours. So yeah, like I said at the beginning, it didn't really need hot water. I have ways of making hot water, and it's all about the compost. So, but this was a fun experiment, and yes, you can definitely get hot water out of a pile of compost. All right, so let's have a look at what's going on with the data and the computer stuff here. So right now, the temperature in the top of the pile, the top sensor, 104.8. I'll just change 109, 103.4. And then the high and the lows since midnight are, you see them here, 104, 106, 103, 105. So things are dropping, and it's been really cold. Last night it was 4 degrees was the low, and we've had a cold streak, which I'll talk about a little bit more in a second. But 6 weeks out, these are the temperatures compared to 160 where things started. And these are the max temperatures that I've recorded. I did see 160 on the graph, and you see it here. But whatever, 156, 160, something like that. And then the bottom got as hot as 148. And as soon as it was built, you'll see down here that the top temperature is the top sensor, and it held that way true for until about the 27th. About 3 weeks into it, the top was hotter. But if you look down here, I've got this is the outside temperature, and I would love to have them on the same graph, but that's a learning curve I'm on with this graphing software. But anyways, you can see a correlation, and especially right here, things really dropped pretty steeply, and that coincided with the drop in the ambient temperature. And yeah, we're having a first real December here that we've had in some time, where we're below freezing pretty substantially. So, but it's reflected in the pile. And these little dips here is when I would draw. I would start the siphon, and really, I wasn't washing dishes or as anticipated with it. I just heat the water on the rocket stove and use it like that. But I would use it as a space heater, so I would sometimes turn it on at night. So in the morning, that bucket would be warm. But of course, this is I'm right next to a rocket mass heater, which is doing the job. So again, I didn't need that so much. But this is great, kind of cool to look at it. And you'll see when I was first taking draws, look at these little humps here, how little difference it made in the overall temperature of the pile. And you see the bottom was largely just unaffected. Um, but yeah, the top was the top and the bottom was the bottom. And then here the bottom flipped um, and became the warmer spot in the pile. And I think that is because, well, let's talk about design here a little bit. I was referencing the book, the Compost Powered Hot Water Heater, which I didn't talk about in the other video, but a great book by Galen Brown, and he expands on the work of Jean Pain and lays it all out. But his recommendation, his recipe is at least a 40-yard pile. Mine, in the end, turned out to be about 22 yards. So, and also taller for this. And I think if it were taller, then this happening, this switch for when it got cold, I think that would help hold the heat quite a bit. But who knows? It's all just speculation. And then down here, I just have the highs and the low temperatures. So this is the bottom high. Each day, I would track the high temperature of that day. And again, interesting. Not much of ambient change there, but things really dropped. About a week into the pile. Um, well, overall, things have been pretty steady like this. This is the bottom and the top, and they're a degree and a half difference, and sometimes they touch and so on. But the way I was looking at it is the last hour. So when I made a draw, I could really see that clearly. And then the 3 hours, it just gives me a different perspective. And here's 1 week, and look at this last week, just the drop because of this cold snap that we're in. I thought it would be a little more resistant with the straw bales and all that. And I did talk about putting those leaf bags on top, but those leaves got used for other things. And I don't know. I'm not monitoring it that closely. So that's kind of what the data shows. But I must admit, it's much shorter lifespan than I would have guessed. And I attribute that again to the size. Um, Back in the book, they recommend 900 feet of black pipe and a 40-yard pile. So, yeah, I could see that making a difference. But would it be enough? I'm not sure. Will I do it again? Probably not. Was it worth it? I guess we'll see when the compost gets unveiled in the spring. So stay tuned for that.